I will start with something that might surprise you. The speed of light was one of the first things humans ever measured about the universe with real precision. For most of human history, we believed light had no speed at all. It simply was. You opened your eyes, and there the world stood instant, eternal, waiting. There was no delay, no journey, no distance between the source and the seer. Light we thought didn't move, it appeared. But the universe does not bend itself to the assumptions of our senses. Please like and subscribe, because this journey will change how you see our place in the universe. Prepare yourselves. We begin. In the 1600s, that illusion began to crack. Far from the bustling cities of Earth, high above in the cold reach of the outer solar system, Jupiter's moons danced around their giant host in a rhythmic clockwork. A Danish astronomer named Ole Rømer was among the first to listen carefully to this celestial rhythm. He wasn't looking for universal truths. He was simply tracking the eclipses of Io, the innermost Galilean moon. And yet, what he noticed would change everything. Sometimes, Io's eclipse arrived early, sometimes late. When Earth was closer to Jupiter, it was punctual, but when Earth was farther away, the moon lagged behind schedule. At first glance, this made no sense, but Rømer saw the pattern. It wasn't the moon that was speeding up or slowing down, it was the light. The extra time wasn't in the moon's motion, it was in the delay of light itself traveling across that extra stretch of space. And from this, with crude instruments and sharp insight, Rømer estimated light's speed to be around 140,000 miles per second, astonishingly close to the modern figure of 186,282. In that moment, the veil was lifted. Light, once assumed divine and instantaneous, had a finite speed. It moved. It was part of time, not beyond it. It took time to cross distance. Like anything else, this revelation didn't just rewrite the rules of optics, it rewrote our position in the cosmos. For the first time, we realized that when we gaze at the heavens, we are not seeing the now, we are seeing the then. Every star, every flicker, every glowing nebula is a message from the past, racing through the vacuum at the universe's ultimate pace. And yet, Rømer's discovery was just the beginning. The centuries that followed saw science take hold of this revelation and refine it. Physicists built cleverer tools, constructed rotating mirrors and intricate experiments. They bounced light between distant mountains, measured the delay in reflected glimmers. By the time the 1800s arrived, we could measure the speed of light to the last decimal. But with greater precision came a deeper problem. It started with a train and a baseball. You're on a train, moving at 60 miles per hour. You throw a ball forward at 20. To someone on the ground, the ball is moving at 80. Simple. Speeds add. This is how motion works. Always has. So what happens if you shine a flashlight on that same train? Shouldn't the beam move at the speed of light plus the train's speed? It didn't. It never did. Enter the Michelson-Morley experiment. 1887. A quiet attempt to measure the slight difference in light's speed as Earth moved through space. The Earth is orbiting the Sun at 67,000 miles per hour. Surely, they thought, light traveling with that motion would appear different than light traveling against it. But no matter what they tried, no matter the direction, the time of year, the speed of the Earth, light always traveled at the same speed. Every single time. It didn't care about your motion, or Earth's, or the direction of the wind. It was constant, immutable, absolute. This was not just unexpected. It was impossible, at least, if the world behaved according to Newton's laws, according to everything we thought we understood. Desperate, scientists invoked invisible forces ether, a mythical substance they claimed must be filling the universe, secretly carrying light waves like a cosmic ocean. But the experiments kept saying no. Light speed was a universal constant, period. And that simple truth shattered physics. It defied the way we believed reality was built. Because if light speed is constant for all observers, if it doesn't change no matter how fast you're moving, then something else must be changing instead. Something deeper, something more intimate, something terrifying. Time itself. And this is where the story becomes something more than science. It becomes a revolution in how we understand existence itself. And into the rubble of broken equations and shattered assumptions walked a young man with no laboratory, no credentials, and a mind that saw the world differently. His name was Albert Einstein, and he was about to finish what Roma started. What if time is not what you think it is? What if the ticking of your clock, the beat of your heart, the rising and setting of the sun are not universal truths, but local illusions? What if motion doesn't just change where you are, it changes when you are? In the early 1900s, one man dared to ask such questions. A 26-year-old patent clerk who worked alone, without a university, a laboratory, or even a blackboard. His name was Albert Einstein, and he wasn't just trying to fix the broken rules of physics. He was listening to the universe whisper a new language, one where time bent, space shrank, and the speed of light became a kind of holy constant, written into the bones of reality itself. Einstein's insight was radical in its simplicity. He proposed just two ideas, two principles that would tear through centuries of established thought. The laws of physics are the same for all observers moving at constant speed. The speed of light in a vacuum is always the same, no matter how fast you're moving. These weren't speculations, they were axioms, foundations, and from these two ideas, a universe of consequences unfolded, each one more mind-bending than the last. Because if light speed can't change, then everything else must. Imagine again, you're riding a train, but this time, it's moving at half the speed of light. Now shine a flashlight forward. Common sense says that beam of light should travel at its usual speed plus the speed of the train. But Einstein's theory says no, everyone, whether standing on the train or watching from a platform, will measure that light as moving at exactly 186,282 miles per second. So, what gives? To protect the constancy of light's speed, time itself must slow down on the train. Distance must contract, mass must increase. Reality must bend to obey this cosmic speed limit. This wasn't science fiction. It wasn't even optional. It was mathematical necessity. This was the birth of special relativity, published in 1905. A theory so elegant and terrifying it left physicists stunned. The cosmos, Einstein showed, is not made of space and time separately. It's made of a single fabric, spacetime, a woven continuum where motion through space changes how you move through time. And the speed of light? It isn't just how fast photons travel, it's how fast cause can become effect. It's the ultimate speed of reality. Try to push past it, and the very geometry of existence fights back. Picture this. You're in a spacecraft, not one powered by combustion or chemistry, but by something unimaginable, some engine that lets you accelerate continuously, faster and faster. At first, things feel normal. Doubling your speed takes twice the energy. But as you inch closer to the speed of light, something strange happens. At 50% the speed of light, Newton's laws start to feel off. You need 15% more energy than expected. At 90%, you need more than double. At 99%, it takes 7 times more energy to go just a bit faster. At 99.9%, that number jumps to 22 times. And to actually reach the speed of light, you would need infinite energy. Not just a lot, infinity. More energy than exists in the entire observable universe. Why? Because the closer you get to light speed, the more the universe pushes back. You grow heavier, not physically, but relativistically. Your mass increases. Time slows to a crawl. Distance shrinks to a razor's edge. The universe is warning you. You do not belong here. This isn't just a theoretical game. We've tested it. Every day, in particle accelerators, like CERN's Large Hadron Collider, we slam protons together at 99.999999% the speed of light. These particles carry the kinetic energy of high-speed trains, but no matter how much energy we pump in, they never reach light speed. Instead, they become more massive, Their internal clocks slow, they live longer, they travel further, and they obey every prediction Einstein made over a century ago. The cosmic speed limit holds, but what is this limit really made of? Why is it there? Einstein showed us that light speed isn't just a number, it's a conversion factor between space and time, between mass and energy, between possibility and paradox. When he wrote the now famous equation E equals mc squared, he wasn't just giving us a tool to build bombs or power stars. He was revealing something deeper. Mass and energy are the same thing. Matter is frozen light. Light is liberated matter. And see, that sacred letter in the equation isn't just shorthand for speed. It is the bridge, the scale, the sacred ruler by which the universe measures everything. And so, we return to the question, why can nothing go faster than light? Because to do so would break causality. It would allow effects to precede causes. It would tear the fabric of reality into contradictions. Without the speed of light, there would be no order, no sequence, no becoming, just a chaotic smear of past and future with no direction, no meaning. The universe would be impossible. Time, as we know it, would collapse. And yet, even within this cosmic boundary, the consequences are surreal. Clocks run slower on moving trains. Distances shrink for speeding astronauts. Your twin who leaves Earth at near light speed returns years later, barely aged, while you've grown old. These aren't thought experiments. They've been measured, verified, observed. We live in a universe where speed warps time, and light defines the edge of what is possible. The train didn't just break physics. It rewrote it. It showed us that we are not passengers in a clockwork cosmos, but travelers in a pliable, humming web of light and time. A web that resists our intrusion, that guards its deepest truths with paradoxes, infinities, and elegant laws. And from this revelation, a new question emerged. If the speed of light is the speed of causality, what happens when we try to exceed it? Imagine sprinting down an endless road. You pump your legs faster, harder. Your breath tears through your lungs like wildfire. The wind howls against your skin, but no matter how fast you go, the finish line never gets closer. You're chasing a phantom, a mirage. This is what it means to chase the speed of light. To understand this wall, the one no object can cross, we must leave behind our instincts. Our everyday experience whispers that if you just try harder, push further, fuel more, you'll get there eventually. But the universe has written a different rule into its bones. A rule so absolute, so elegant, that it halts even our boldest dreams. The rule is this: the speed of light is the maximum speed at which information, energy, and causality can move through the fabric of space-time. Nothing with mass, not rockets, not particles, not planets, not people can ever reach or exceed it, period. And not because the universe won't let you, but because the universe can't. Here's why. As you approach the speed of light, three strange things happen simultaneously. Your mass increases. Not visibly, but relativistically. The faster you go, the more energy you carry. But in Einstein's universe, energy and mass are the same thing. That energy adds to your mass, making you harder to accelerate. Time slows down for you. From your perspective, your own clock ticks normally, but to an outside observer, your seconds stretch. At near light speed, 1 second for you could be hours, days, or years for them. Distances shrink in your direction of travel. The faster you go, the more space contracts. Galaxies that were light years away begin to collapse into your windshield. You become a paradox in motion, heavier, slower in time, faster in space. Reality distorts around you, warps like heat off desert asphalt. And yet, despite all this, you still cannot reach the speed of light. Let's talk numbers. At 90% the speed of light, your mass increases by a factor of 2.3. At 99%, it increases over 7 times. At pedwar arbeimmdeg a fedwar ugain %, you're at dau hugain times your original mass. At 99,999%, it's over 200 times. You'd need more and more energy just to move an inch faster. It's like trying to push a mountain uphill with a feather. The closer you get, the heavier you become, until finally, to reach light speed, you'd need infinite energy to move infinite mass. That's the wall, not a wall of concrete or steel, but a mathematical wall, a law that lives in the equations of relativity, unbroken in every test we've ever run. And it stands, not to punish us, but to protect the logic of the cosmos. Because if we could break that wall, if we could travel faster than light, we would unravel time itself. Imagine this. You board a ship and travel faster than light to a distant star. There, you send a message back to Earth at light speed. You'd arrive before the message did. But from another point of view, you'd arrive before you even left. You'd have moved backwards in time. And if that's possible, then paradoxes arise. You could stop your own launch, prevent your own birth, rewrite history. The entire timeline collapses into chaos. Causality, the very idea that A causes B, disintegrates. And so, the universe erects the wall, not arbitrarily, not out of cruelty, but out of necessity, to keep the arrow of time pointed forward, to preserve meaning, to prevent the future from eating the past. But what about light itself? Why is it allowed to ride the razor's edge? Because light is massless. It has no rest frame. It does not experience time. A photon, the particle of light, is born and from its own point of view instantly arrives at its destination. No seconds pass. No journey occurs. For light, there is no between, just origin and arrival. It travels not through time, but outside of it. That's the secret. Light doesn't approach the speed limit. Light is the speed limit. It is the measure against which everything else is compared. So what happens if you try to beat it? Let's say we build the most powerful spacecraft imaginable, engines fueled by black holes, propulsion systems driven by the rotation of spacetime itself. We accelerate, faster and faster, consuming stars, devouring quasars for energy. At 99.9999999% the speed of light, we've turned decades into centuries from the outside world. Earth has aged, civilizations have risen and fallen. But inside the ship, time has nearly stopped. The crew hasn't even aged a year. Still, we have not broken the barrier. Still, we are chasing the light, and we always will be. Because the wall of infinite resistance is not just real, it's fundamental. It's woven into the code of the cosmos. But here's where the story gets even stranger. Because even though we can't break that wall, the universe might. In the shadowy corners of modern physics, new ideas stir. Hypothetical particles called tachyons, which could only exist faster than light. Speculative tunnels in space-time called wormholes, which might allow shortcuts through space and time. Twisting geometries, negative energy, quantum entanglement. They hint at loopholes, not violations of the wall but workarounds. Side doors, cracks in the foundation. Could there be other rules? Other layers of reality where light is not the limit? We don't know, but we're searching. And so, we live in tension, caught between the desire to explore the stars and the reality of the cosmic speed trap, between our human hunger for the infinite and the cold, beautiful truth of Einstein's equations, between our dreams of going faster and the silent resistance of the universe whispering, no further. But in that resistance, there is meaning, there is structure, causality, time, life, because if nothing could go faster than light, it means the story of the universe has a direction, a beginning, a middle, an end, and maybe, just maybe, that's what makes it a story worth telling. What if now is a lie? What if the moment you're living this breath, this thought, this very second is not the same moment someone else is living, simply because they're moving differently or they're farther away? What if now doesn't exist, not as a universal truth, but as a fragile illusion of perspective? Welcome to one of the most disturbing truths ever discovered. There is no absolute now. To our senses, reality unfolds in unison. You flip a switch, the light turns on. You hear thunder, you feel rain. You speak a word, someone hears it. Cause and effect. time and sequence. It feels solid, but according to Einstein's special relativity, time is not a rigid river that flows the same for everyone. It is a flexible dimension, interwoven with space. The faster you move, the more warped your sense of time becomes, not just for clocks but for reality itself. Let's imagine two observers. One is standing on Earth, watching the stars. The other is on a spaceship, traveling near the speed of light. They both look out at a distant supernova, light years away. A star explodes. A blaze of light races across the galaxy. Now here's the twist. The earthbound observer might say, "The explosion is happening now." But the traveler might say, "That explosion won't happen for years." And yet another traveler, moving in the opposite direction, might insist, "It already happened long ago." Who is right? They all are, because in the universe of relativity, simultaneity events happening at the same time is relative. It depends on your frame of reference, your motion through space, your distance, and your velocity. What you experience as now may be someone else's past or someone else's future. This isn't philosophy. This is physics. Think of space-time like a massive loaf of bread. Each slice is a now, a snapshot of the universe at a given instant. But depending on how you move through space-time, your slice tilts. Your now is cut at a different angle. And here's the weirdest part. There is no universally agreed upon way to cut the loaf. There is no master clock, no cosmic ticking hand that defines what's happening at the same time across the universe. Time is not global. Time is local. Let's go deeper. Imagine you're floating in space, far from any gravity. You look toward Earth, and through your telescope you watch your friend waving at you. Because of the time light takes to travel, you know you're seeing the past. Maybe they waved an hour ago, you wave back. But now imagine you suddenly accelerate. Not a gentle speed up, but a sharp jolt like punching the gas pedal on a starship. Einstein's equations say your perception of now across the universe instantly shifts. That same friend you were watching an hour in the past? After your acceleration, they might now be, according to your new frame, laughing at a joke days in the future. By changing your motion, you changed your slice of reality. You altered your present. You redefined the now. And this gets us to something deeply unsettling. Time is not a single line. It's a landscape. And what you see depends on where you stand and how fast you move. In one part of the universe, a planet is being born. In another, a civilization is collapsing. In another, a person is just now whispering their first word. All of these could be happening now, but only depending on who you are. There is no privileged observer, no divine point of view, no master narrator. Time is subjective. Reality is a web of perspectives, each slicing space-time in its own direction. Now, let's raise the stakes. If simultaneity is relative, and different observers disagree on what's happening now, then our understanding of causality, what comes first, what follows, is suddenly in jeopardy. What happens when two events are so far apart in space and so close in time that their order depends on who's watching? Could one person say, event A caused event B, while another says B caused A? In some space-like separations, yes, but nature has a safeguard. No information can travel faster than light. This rule preserves causality. It draws a line around which events can influence which. If two events are outside each other's light cones, they're causally disconnected. No paradox can arise. You can't send a message from one to affect the other. Even if two observers disagree on which came first, they can't use that disagreement to change the past. So the fabric remains consistent, even if it's bent. But this still leaves us with the existential bombshell. The present moment is a myth. It's a convenience, a useful fiction, a trick of synchronized clocks and shared assumptions. But out there, beyond Earth, beyond your motion, beyond your frame, reality doesn't share your now. The past and future are not waiting somewhere behind or ahead. They are smeared across space-time, like colors in a cosmic painting. Your motion defines which parts of the painting you see as now. Time is no longer a flowing river. It's a block, a frozen structure, and your consciousness is just a flashlight, sweeping through the block, illuminating one slice at a time. Now pause. What does this mean for you? It means you're not riding the wave of time. You're constructing it. Your now is a narrative, a personal cut through a 4D universe. It also means something beautiful. Somewhere in the block universe, your childhood still exists. Somewhere, your first love is still unfolding. Somewhere, your final breath has already left your lungs. Not as memories, not as predictions, but as locations, coordinates in space-time. You can't visit them, you can't change them, but they are part of the tapestry, eternal, immutable, forever written. And if that doesn't awaken awe, then maybe the next question will. If time is a block and all moments exist equally, then why do we experience the now at all? Why does consciousness move? Why do we feel time passing? What is this arrow that carries us forward? And can it be reversed? Can it ever stop? A glass falls, it shatters. You can't unshatter it. You can't catch each shard in reverse, rewind the spill, restore the wine. Time, for all its strange relativity, has a direction, a forwardness, a current, an arrow. But if Einstein was right, if time is just another coordinate, and all moments are equally real, why do we remember the past, but never the future? Why do we age and not de-age? Why does order collapse into chaos, but not the other way around? Why does time flow at all? In the equations of physics, time is symmetric. The math doesn't care if time moves forward or backward. Whether you're calculating the orbits of planets or the dance of atoms, the equations work either way. They're reversible. This means that, at the deepest level, nature doesn't insist on a direction. So where does the arrow come from? The answer is one of the most haunting concepts in all of science: entropy. Entropy is a measure of disorder, a tally of how many ways a system can be arranged. A tidy room has low entropy, few ways to be neat. A messy room, high entropy, countless ways to be chaotic. Now imagine the universe. At its birth, it was exquisitely ordered. A hot densifier ball, smooth, uniform, pure, but ever since, it's been falling apart. Stars burn out, galaxy drift, systems break down, entropy increases, always. This is the second law of thermodynamics. In an isolated system, entropy tends to rise, and in that rise lies the arrow of time. Let's walk through a thought experiment. Take a deck of cards, perfectly ordered, ace to king, by suit. Now shuffle it. What happens? Order vanishes. Patterns dissolve. Chaos wins. You could, by chance, reshuffle into perfect order again, but the odds are astronomical. So in practice, it doesn't happen. This is time's one-way street. Not because it's forbidden to go backward, but because the odds are overwhelming against it. You remember the past, not because the past exists more than the future, but because entropy was lower in that direction. Memory itself is an echo of order. Now take a breath. This means the universe you live in is not flowing forward. It's degrading, like a great machine winding down. The passage of time is not an illusion, but its direction is born from statistics, not necessity. Entropy is not a force. It's a probability field. A tide that favors mess over order, decay over growth, diffusion over concentration. The arrow of time doesn't point forward because the universe wants it to. It points forward because there are more futures than pasts, more ways to break than to build, more ways to forget than to remember. But there's a deeper mystery still. If entropy defines the arrow of time, then what set it in motion? Why was the universe born in such a low entropy state? This is one of the most profound questions in cosmology. Think about it. The early universe was hot and dense, filled with radiation and particles, a roiling sea of energy. You might think it was high entropy, but gravitationally, it was simple, smooth, uniform, and that's the key. In gravity's strange logic, clumps have more entropy. Galaxies, stars, black holes. So the early cosmos, flat, smooth, even was the gravitational equivalent of a tight, wound-up spring. Time began, already under pressure, and since that moment, the universe has been unwinding, entropy increasing, complexity rising, the arrow drawn. But what if the Big Bang wasn't the beginning? What if our universe is part of a larger cycle, a bounce, a rebirth, a reflection? Could time's arrow reverse in some regions? Could another universe run backward? Some theories say yes. In models of the multiverse or quantum cosmology, there may exist pockets of space-time where entropy decreases where the arrow points inward rather than outward. To us, that would look like time running in reverse. Not just rewinding events, but rewinding causality, awareness, identity, a world where people unlive their lives, where stars unburn, where choices are undone, and yet such a world would make perfect sense to those inside it. To them, we would be the backward ones. This brings us to a terrifying but beautiful realization. The arrow of time is not built into reality. It is built into our perception of it. Your birth came before your death because that's how your memories are wired. You see the past, not the future, because your brain is a record of what was, never what will be. You experience time as a line, not because it is one, but because that's how your biology, your chemistry, your consciousness was carved. But from the outside, from the cosmic vantage, time may be no arrow at all. Just a landscape, just a map, just everything, all at once. And yet, within this vast block, the arrow gives meaning. It gives narrative, struggle, aspiration, regret, redemption. It gives life the feel of a journey. We plant seeds, and they grow. We love, and it deepens. We fall, and we rise again. All because we believe the future lies ahead. All because we believe there is something to reach for. But ask yourself, if time is ultimately a statistical mirage, if the arrow is just the path of least resistance, then what does that say about free will? About destiny? About change? Can we alter the trajectory? Or are we passengers on a one-way ride, carved by entropy and cradled by chance? Is the arrow pointing forward because we choose to walk forward? Or do we walk forward because the arrow chooses us? As we drift through the wake of entropy's tide, there's one more question waiting for us in the darkness. Not about time's direction, but about its destination. Because if entropy must always increase, if disorder is destiny, then what happens when the universe runs out of order to give? What lies at the end of the arrow? And is it the end of everything? No ticking clocks, no burning stars, no motion, no change, no memory, no future, just silence. This is not science fiction. This is the final forecast of physics. The heat death of the universe, not an explosion, not a collapse, but a slow fading into nothing, a vanishing not of matter but of possibility. To understand this haunting fate, return to the second law of thermodynamics. Entropy must increase. Every action, every breath, every supernova, every chemical bond spreads energy, evens out differences, wastes order. Imagine the universe as a cup of hot coffee in a cold room. At first, the coffee steams, the molecules swirl, but over time, the heat bleeds away. The room and the cup equalize. No more emotion, no more contrast. This is thermal equilibrium, and the universe, too, is heading there, toward a state where all gradients are gone. No hot, no cold, no stars, no suns, just a thin soup of particles, drifting through endless, undisturbed space, a cosmos maxed out in entropy. The term heat death is misleading. It sounds fiery, dramatic, but the reality? It's the ultimate freeze, a cosmic stillness so absolute that time itself loses meaning. Because without change, without before and after, how do you measure time? No clocks tick in the heat death, not because clocks are broken, but because nothing happens anymore. Let's rewind a bit. Right now, our universe is expanding. Space is stretching. Galaxies fly apart like sparks from a firework. Stars are born, burn bright, and die in glory. But this era is temporary. As galaxies race away, resources dwindle. Fuel runs out. Star formation slows. Black holes swallow the remnants, and then even they die. Yes, even black holes, the supposed graveyards of matter, are not eternal. Thanks to a process called Hawking radiation, they slowly leak away mass over unimaginable time spans. A supermassive black hole might take 10 to the power of 100 years to evaporate. That's a 1 followed by 100 zeros, an era so long, it's effectively infinite from a human view. And when the last black hole finally fades, there will be nothing left that can do anything. No energy gradients means no work, no machines, no life, no systems that can store or process information, no memory of what once was. It's not destruction, it's dilution. Not the end of space, but the end of structure. The entire universe becomes a flat line, a sterile bath of photons and elementary particles, stretched so far apart that they can drift for trillions of years without ever interacting. The canvas remains, but the paint has thinned beyond meaning. Time, by its nature, is tied to change, to causality, to difference, and in the heat death, there is no difference left to note, no events to mark one moment from the next, no boundaries between what was and what island. And so, in a sense both poetic and profound, time ends, not with a bang, not with a fade to black, but with an eternal, unblinking grey. But here's the riddle. If everything dies, if time, energy, and structure all dissolve, what remains? Is there a deeper layer of reality beneath this decay? A reset button? A new spark? Or is this the final note of the cosmic symphony? Some scientists believe the heat death is truly the end, a terminal entropy, a tomb of potential, but others whisper of rebirth. In quantum cosmology, vacuum fluctuations, random blips in the quantum field can spawn new universes, like foam bubbling from nothing. Could our own Big Bang have been such a fluctuation? A cosmic phoenix rising from entropy's ashes? If so, then the heat death is not death at all. It's gestation, a womb for a new cosmos, a universe beyond ours, waiting to be born. Others suggest something even stranger. That information can never be truly destroyed. If true, then even in the heat death, the story of the universe remains encoded in the subtle structure of space itself, like a ghost imprinted on the walls of time. Somewhere, somehow, the echoes of stars, of laughter, of love might still hum in the void, not lost, just dormant. And then there's you. Your life, your memories, your hopes, they seem so urgent, so fragile, so temporary. But they are part of this vast entropy tale. You are a swirl of energy riding the great cooling wave. Your thoughts are thermodynamic processes. Your love, your struggle, your art, these are rebellions against equilibrium, flashes of order in a sea of chaos. Each act of creation is a miracle of imbalance, a refusal to fade. You are the universe momentarily reversed, a pocket of resistance, a fleeting story written in fire. So, as we contemplate the heat death, don't just mourn the ending. Marvel at the now. Marvel that you are here, before the silence, that you are part of the brief, impossible window where anything at all can happen. A window where stars shine, and time ticks, and stories matter. You live in the golden hour of the cosmos, and though the curtain will fall, what happens on this stage echoes forever. Because even in the vast, cold future, the fact that you were changes what the universe island. What if the limit isn't real? What if, buried deep in the equations of space-time, there's a loophole, a secret tunnel under the prison wall of physics? A path to faster than light? It's a question that has haunted scientists and dreamers alike for over a century. Can anything move faster than light? And if it could, what would that mean for reality? Because light speed isn't just a speed limit, it's the guardian of causality, the enforcer of order in the universe. Break that barrier, and you might break time itself. Let's begin with Einstein. In his special theory of relativity, he showed something shocking. The speed of light, about 299,792 kilometers per second, is the cosmic constant. No matter how fast you move, light always travels at the same speed, relative to you. This unyielding rule warps everything around it. Time slows down the faster you go. Mass increases, distances contract, approach light speed, and the energy required becomes infinite. You'd need an infinite amount of fuel to reach it, which means nothing with mass can ever reach, let alone surpass, the speed of light. The universe has spoken, but humans are stubborn. We don't like fences, even cosmic ones. We ask, what if there's a way around? Not by pushing mass faster, but by changing the rules of the field itself. And that's where the science starts to flirt with the fantastic, because buried within the math of general relativity are some truly wild ideas. Take the Alcubierre drive, proposed in 1994. It's a theoretical construct, a warp bubble. Inside the bubble, a spacecraft sits still, but outside, space contracts in front of it and expands behind. The ship doesn't move through space. Space moves around the ship, and if space itself can stretch and fold like a rug on a hardwood floor, then in principle, the ship could ride that ripple faster than light. No speed limits are broken locally, but to an outside observer, the ship vanishes and reappears across galaxies. This is not science fiction, it's actual physics. But, and it's a big but, it requires exotic matter, a form of energy with negative mass, something we've never observed, something that might not even exist, and even if it did, the amount required is staggering. It's like asking, could we build a time machine if we had a black hole made of unicorns? Still, these ideas won't die, because they point to something deeper, that the structure of spacetime might be malleable. And if spacetime is not a static backdrop, but a dynamic fabric, could there be shortcuts? Could wormholes exist? A wormhole, theoretically, is a tunnel through the fabric of spacetime. Imagine folding a piece of paper, punching a hole through it. The two distant points normally separated by light years are now joined. Travel through the tunnel, and you emerge light years away in no time at all. Einstein and Rosen first theorized this, calling it a bridge. But again, the same problem arises. You'd need negative energy, anti-gravity stuff to hold the tunnel open. Wormholes collapse instantly under normal conditions. You'd be crushed before you said warp speed. And yet, quantum physics adds another twist. The vacuum of space is not empty. It seethes with fluctuations, tiny blips of energy that pop in and out of existence. Could these fluctuations briefly spawn quantum wormholes? Could entangled particles linked across light years offer clues? Some physicists now propose that entanglement and wormholes are the same thing, just seen from different angles. ER equals EPAR, they call it. A theory suggesting that every connection in quantum physics might be a tiny bridge in spacetime. If that's true, then the entire universe is a network of invisible threads, not a cold void, but a woven fabric of potential. So, back to the question, can anything go faster than light? No, not in the way we normally think, but maybe yes, in ways that rewrite the rules of distance itself. Maybe speed isn't the key topology island. Maybe the road to other stars is not a straight line, but a folded map, a hidden passage, a rewrite of geometry. But here's the philosophical sting. If faster than light travel is possible, then so is time travel. Why? Because in relativity, space and time are two sides of the same coin. Change your path through space dramatically, and you twist your path through time. A ship that jumps faster than light could, under some frames of reference, arrive before it leaves. That's not just confusing, it's causality breaking. The grandfather paradox, the snake eating its tail, effect preceding cause, and physics does not like that. This is why many believe nature has a built-in cosmic censorship clause, that the universe prevents such violations by making FTL impossible. But what if it doesn't? What if the reason we haven't seen aliens is because they're not crossing the galaxy in ships? They're folding it, tunneling through dimensions we barely understand. What if they aren't elsewhere in space, but elsewhen? What if our descendants, 10,000 years from now, learn to harness space like origami, and what we call UFOs aren't visitors from Alpha Centauri, but from Earth's own future? This isn't science fiction. This is what relativity allows, once you permit FTL. But beware, once you break the speed of light, you invite paradox. You invite timelines that devour themselves. You play with the very logic of the cosmos. So perhaps it's mercy that the limit exists. Perhaps the universe knows what we don't. That stability requires boundaries. That freedom without structure becomes chaos. Or maybe, just maybe, the limit is a challenge. Not a wall, but a whisper, a voice in the dark saying, "Come find me." Because if history has shown anything, it's that when humans hear impossible, they sharpen their tools. They dream bigger, they dig deeper, and sometimes, against all odds, they break through. A shadow can move faster than light. That statement feels like heresy, doesn't it? But it's true, at least, in a very specific and revealing way. A laser pointer aimed at the moon can sweep across its surface at a speed exceeding 300,000 kilometers per second. Your hand moves an inch, and the red dot races across lunar dust faster than any particle could. Did you just break the light speed barrier? No, but you brushed up against something just as fascinating: the illusion of speed versus the reality of information. This is a chapter about the exceptions, the cosmic sleights of hand, the strange places in physics where faster than light seems possible, but the universe keeps its secrets intact. Because light speed isn't just about how fast a thing moves, it's about how fast causality moves, how quickly information can travel, and in the strange corners of science, there are phenomena that look like they defy this law, but never truly cheat it. Let's begin with cosmic rays. These are particles, mostly protons, hurtling through space at nearly the speed of light. Some come from the sunday, others from supernovae, and some from origins we can't yet explain. We detect them when they strike Earth's atmosphere, creating showers of secondary particles. And occasionally, just occasionally, these rays arrive with so much energy, they create a bizarre illusion. They seem to be moving faster than light through the atmosphere. How is that possible? Because light, while constant in a vacuum, slows down in a medium. In air, glass, or water, it travels more sluggishly than in empty space. So when a cosmic ray barrels in nearly at full vacuum speed, it can actually outpace the local speed of light in that medium. And when it does, something remarkable happens. It emits a cone of blue light, like an underwater sonic boom. This is called Cherenkov radiation. It's the optical version of a sonic boom, a luminous shockwave. You're watching a superluminal illusion. But no laws are broken, because the particle never exceeds true light speed in a vacuum. It just outruns light in that particular medium. Now let's turn to those moving shadows, or laser dots on distant walls. This trick is simple but deceptive. Imagine you're sweeping your laser across a building a mile away. That red dot seems to move faster than anything could possibly run. But remember, the dot isn't a thing. It's not a particle or wave carrying information from one side of the building to the other. It's a series of unrelated events happening at different locations. Each point on the wall is lit by a different photon emitted at a different moment. Nothing is actually moving from point A to point B faster than light. The illusion comes from how your motion changes the origin direction of the beam. There's no signal, no force, no message sent faster than light. It's a dance of geometry, not physics. Let's go deeper. In quantum mechanics, we encounter something even stranger. Entanglement. Two particles can become linked spooky twins across space. Measure one, and the other seems to know instantly no matter how far away. Einstein called it spooky action at a distance, and it looks like information travels faster than light. But here's the twist. You can't use entanglement to send a message. You can't encode or decode anything useful from the linkage alone. It's like two gamblers across the world flipping coins that always match, but neither can influence the result. The correlation is instant, but the control is not. No signal passes between them. No causality is violated. Another illusion of superluminal behavior, but no true speed is broken. Even gravitational lensing can trick the eye. When light from a distant quasar bends around a galaxy, we sometimes see multiple images of the same object. They appear in different places in the sky. As the galaxy moves, these images can seem to shift, like a slow-motion dance across space. And, under precise conditions, these shifting light echoes can appear to move faster than light across the sky. But again, what's actually moving? Just the angle of incoming light, just our perspective. No actual object, no energy, no information is traveling that fast. It's the parallax of the cosmos, an illusion from light's slow journey across a moving universe. But not all illusions are falsehoods. Sometimes, they point to deeper truths. These faster-than-light phenomena remind us that speed is not always what it seems, that what matters isn't how fast something appears to move, but how fast it can cause something else to change. Causality is the currency of the cosmos, and causality still bows to the speed of light. These exceptions, these shadow games, are like whispers behind a locked door. They tempt us with what might lie beyond, but remind us that we're not there yet. So why does the universe allow these illusions? Maybe to teach us humility, to show us that perception is a slippery thing, that not all speed is real, not all motion means power, not all change means causation. Or maybe, like mirrors in a magician's act, they are there to distract, while the deeper secrets lie somewhere else entirely. Because here's the haunting part. For every illusion we uncover, there may be one that isn't an illusion at all. A real hole in the wall, a real crack in the speed of light. We don't know, not yet. But the shadows, the light cones, the radiation bursts, they all hint that the truth might not be found by going faster, but by going deeper. In the end, speed is only a frame of reference. But meaning travels differently. It reaches us not in kilometers per second, but in moments of awe. And in those moments, we are reminded there are things in this universe that move faster than light. Ideas, wonder, the feeling that there is something more. There's a wind we cannot feel, a pull we cannot see, dragging galaxies across billions of light years towards something we do not understand. This is not fiction. This is astrophysics. Somewhere, out there in the black, beyond the Virgo cluster, beyond our maps, beyond even the veil of observable space, there's a force that's drawing entire superclusters toward an invisible destination. We've named it the Great Attractor, but naming is not knowing, and knowing feels like chasing a ghost. Imagine this. You are floating in space. The galaxies around you appear to move slowly, methodically, all shifting in one broad direction, like leaves caught in a gentle river current. But the river isn't local. The river isn't made of stars or dust. It's made of motion itself, and it's not slowing down. It's accelerating. In the late 20th century, astronomers studying cosmic microwave background radiation, the afterglow of the Big Bang, noticed something strange. Our entire local group of galaxies, including the Milky Way, was drifting at high speed toward a particular region of space. This wasn't just orbital wobble. This was a mass migration, an enormous bulk flow of matter. Not random, not chaotic, directed. It was as if the entire sky had tilted slightly, and everything was sliding downhill. The term they coined for this invisible destination? The Great Attractor, somewhere near the Centaurus cluster, 150–250 million light-years away. An immense concentration of mass, hidden behind the dense dust of our own galaxy, the so-called zone of avoidance. But the more we looked, the less sense it made, because even after correcting for visible matter, even after including everything we could see with our most sensitive instruments, the math didn't add up. The gravitational pull was too strong, too vast, too precise. And that's when things got darker. Enter dark flow. In 2008, researchers analyzing data from the Wilkinson Microwave Anisotropy Probe, WMAP, discovered another mystery. Clusters of galaxies were not just moving toward the Great Attractor, they were streaming far beyond that point, in the same direction, at incomprehensible speeds. This wasn't motion caused by any known local structure. It was as if something outside the observable universe was dragging everything toward it, our deeper, colder gravity, from a region we cannot see, and perhaps will never see. Let that sink in. There may be something beyond the edge of our cosmic horizon, pulling entire swaths of the universe toward it. Not just stars, not just galaxies, superclusters, walls of galaxies, entire threads in the cosmic web, all being pulled without friction, without resistance, in one eerie direction, a motion we cannot stop, a destination we cannot reach, and a force we cannot define. That's dark flow. But here's the real paradox. This phenomenon appears to challenge one of cosmology's most sacred principles. The cosmological principle, the idea that, on large enough scales, the universe is homogeneous and isotropic. In other words, no direction is special, no location is privileged, but if there is a flow across the entire observable universe toward a specific direction, then that principle may be incomplete, or worse, wrong. So what could cause this? One hypothesis: the multiverse. If our universe is just one bubble in a vast foam of cosmic realities, then perhaps another universe more massive, more curved, more ancient, is pressing up against ours, distorting spacetime, leaking its gravitational fingerprints through the cosmic membrane, a kind of inter-universal tide. Another idea: pre-Big Bang structures. If the Big Bang wasn't the true beginning, if it was only the latest cycle in a deeper, eternal process, then perhaps remnants of the previous cosmos still exist, beyond our current light cone. Imagine fossils not made of bones, but of motion. Fossils made of pull, traces of a previous reality, still dragging us toward it, like the whisper of a memory too old to name. Or maybe it's something we've never even imagined. A gravitational singularity with no visible form, a tear in space-time itself, or the edge of a domain where physics as we know it begins to break down. We call it the Great Attractor because we are still children, naming constellations in the dark. But perhaps it is not attracting at all. Perhaps we are falling. And yet, here we are, riding the curl of dark flow, drifting with galaxies in a direction we did not choose, part of a motion too vast to feel. And perhaps that's the greatest humility the cosmos offers. We don't live in a stable grid. We live in a river, one that's still moving, still responding to something further out than light can ever reach. The poet Rainer Maria Rilke once wrote, "I live my life in widening circles. So does the universe. And sometimes those circles ripple not outward, but inward, towards some central mystery we've yet to name. What is it that calls to matter across the void? What force bends the entire sky toward one dark corner? And if we could ride that current to its end, what would we find? A new beginning? A deeper truth? Or the quiet breath of a cosmos beyond our own? What if the universe doesn't unfold like a film reel, but more like a deck of shuffled cards, with every possibility stacked and waiting until one card is drawn and reality is chosen? What if the real speed limit isn't about moving from here to there, but about how fast reality decides? Welcome to the quantum world, where particles don't behave, where cause and effect dissolve into probability, and where the universe, it seems, only becomes real when we look. In the classical world, the world of apples falling and planets orbiting, we imagine reality as solid, knowable, determined. But at the quantum level, reality is smoke. An electron isn't in one place. It's in all possible places, at once. It's a superposition, a wave of probabilities, each location equally real and equally unreal, until, that is, we measure it. And then, the wave collapses. All possibilities vanish. One outcome emerges, and the rest, gone, like dreams never remembered. This collapse, sudden, irreversible, absolute, is one of the greatest mysteries in all of physics. Why does observation change reality? Why does a conscious act, a gaze, a sensor, a detection, seem to force the universe to make a decision? It's as if the cosmos is undecided until we show up to witness it. Until that moment, nothing is real. Everything is potential. The universe is not a place. It's a question, and we are part of the answer. But here's the twist. This collapse isn't just philosophical. It happens at a speed. And that speed? It appears to be instantaneous. Faster than light. Faster than anything. When two quantum particles become entangled, when their fates are woven together like threads in a tapestry, a change in one instantly affects the other, even if they're light years apart. Einstein hated this. He called it spooky action at a distance, because it breaks every rule of locality. It suggests that some kind of invisible handshake happens across spacetime, at infinite speed, not information, not matter, but correlation, the deep alignment of fate. And yet, no one has ever used this to send a message faster than light, because the outcome is still random. The universe doesn't let us cheat causality. It only lets us witness the entanglement of truths. Still, this raises a breathtaking possibility. What if the ultimate speed limit, the speed of light, isn't about how fast things travel? What if it's about how fast potential becomes actual? What if the real boundary is not distance or velocity, but the conversion of possibility into presence? Picture this. The universe is not a movie, but a branching tree. Each moment splits into countless limbs, a multiverse of maybes. You, sitting in this exact spot, are just one outcome of trillions that could have been. And the thing that makes this version real is choice. Not just human choice, but the choice of nature, the roll of quantum dice, the coin flip that decides left or right, yes or no, particle or wave. Reality, in this view, is the echo of decisions made from a deck of eternal uncertainty. Now imagine that every collapse of the wave function, every moment a quantum system decides, is like the tick of a cosmic clock. What if the ticking has a speed? What if the universe is becoming, moves at a regulated pace, and that pace is set by the speed of light? Not as a limit of motion, but as a governor of revelation. Reality reveals itself no faster than that. It's not that we can't go faster, it's that nothing can be known faster. This reorients everything. Suddenly, photons, these packets of light, aren't just messengers. They are priests of reality, gatekeepers, deliverers of truth, one snapshot at a time. Every ray of light is not just a beam, it's a boundary. Beyond it is not just darkness, but non-existence. A canvas not yet painted, a verse not yet sung. The speed of light may not be how fast we go, but how fast the universe allows us to know what island, and if that's true, then the limits of light are also the limits of consciousness. Our awareness doesn't just live inside our brains. It rides on photons. It echoes in electrons. It collapses wave functions with every breath we take. We don't just observe the universe, we help write it. So next time you look at a star, remember, the light took millions of years to reach you. But the moment you see it, you collapse its final destiny. You become the final arbiter of that photon's fate. You make it real, and perhaps you always were meant to. The quantum world suggests that nothing is definite until someone, something, somewhere chooses. So maybe the deepest truth of speed is not in acceleration or velocity, but in how quickly the cosmos chooses to become itself. Close your eyes. Now imagine this. Every second of your life, every heartbeat, every joy, every sorrow is not behind you or ahead of you. It still exists. Right now, like a book already written, like a song that has never stopped playing. What if you are not walking through time, but experiencing one page at a time in a cosmic story that already exists in full? This is not fiction. This is physics. Einstein called it the block universe, a view of reality where past, present, and future are all equally real. Time, in this vision, is not a river that flows. It is a landscape that's simply island, mountains of memory, valleys of possibility. And you're just a traveler, not walking the path, but having the path unveiled, moment by moment. But if all of time exists, why does it feel like it moves? Why do we sense a past that's gone, a future not yet born, and a fleeting present always slipping away? Because we're built to. Because our consciousness is a spotlight. It can only illuminate one moment at a time. Like a film projector clicking through frames, we experience the illusion of movement, not because the frames are moving, but because we are. Imagine you had a being, outside of time, not bound to linear awareness. They would see your entire life at once. Birth, love, heartbreak, death, all equally present. To them, there is no becoming, only being. This is the cosmic contradiction. Time feels so real, so fundamental. But the deeper we dig, the more it looks like a trick of perception. Physics backs this up. In Einstein's theory of relativity, time isn't fixed. It bends, warps, slows down, speeds up, depending on gravity and velocity. Fly fast enough, and time stretches. Stand near a black hole, and seconds become centuries. But how can something so slippery be the foundation of everything? Because maybe it's not. Maybe time is not the engine of the universe. Maybe it's the shadow of something deeper. And here's where it gets stranger. Experiments in quantum physics show that choices made now can affect outcomes in the past. Particles seem to know what measurement they will face, even before the measurement happens. This is the delayed choice quantum eraser, and it suggests something unnerving. The future can affect the past, which raises a chilling question. If time can move backward, then what is it? The ancient mystics, long before equations or colliders, whispered of timelessness, of a place beyond seconds and centuries, beyond cause and effect, a realm of pure being. What if they were right? What if eternity isn't an endless stretch of time, but the absence of it? What if time is not the truth, but the illusion that hides the truth? And yet, this illusion matters, because it gives us narrative. It gives us meaning. Without time, there is no growth, no becoming, no redemption, no story. Time is what allows us to fall and rise, to lose and find, to become something more. So even if it's an illusion, it may be the most beautiful one ever crafted. Now, imagine this. The speed of light, our cosmic speed limit, is not just the fastest speed, but the boundary between the timeless and the temporal. It's the razor's edge, where the eternal becomes the unfolding, where the block universe gets sliced into the movie you call your life, where the timeless chooses to become experience, one frame, one heartbeat, one choice at a time. So next time you feel behind, racing against the clock, lost in regret or anxious for tomorrow, pause. Remember, every moment still exists. Your childhood is still real. Your future self is already alive. Your last breath has already happened and hasn't. You are not a line. You are a whole, azul, woven through eternity. Time is not a jailer. It is a mirror, reflecting back the rhythm of your becoming. And maybe, just maybe, you were never meant to outrun it, only to awaken within it. There is a limit to how far we can see, not because the universe ends, but because light, our messenger across the cosmos, hasn't had time to arrive. 13.8 billion years. That's how long light's been traveling since the Big Bang. And even at 299,792,458 meters per second, there's only so much distance it could cover. We call this the observable universe, a sphere roughly 93 billion light years across. But beyond it, darkness, silence, not because nothing's there, but because light hasn't reached us yet. This boundary is not made of walls or energy. It's made of time. It's not the edge of reality. It's the edge of what we can know. Imagine standing in the center of a massive globe of stars. As you look outward, each point on the surface of that globe represents the farthest light that's reached you. This is your cosmic event horizon. your personal curtain of vision, your light limit. But here's the paradox. The universe is expanding, and not just slowly, it's accelerating. Thanks to dark energy, distant galaxies are racing away from us faster than ever before. Some are moving faster than the speed of light, not through space, but with space. You see, relativity doesn't forbid space itself from stretching, and when it stretches fast enough, light from those galaxies can never reach us. They slip beyond the veil, not because they vanish, but because their message is forever delayed. It's like standing on a shore, watching ships sail toward a horizon they'll never return from. Not because they fall off the edge of the world, but because the ocean itself pulls them away faster than any sail can resist. Those galaxies still exist. They still shine, but we will never see them again. Their photons will never arrive. They have left our story, even though the story goes on. Now, turn inward. What does it mean to live in a universe where the majority of existence is permanently unknowable? What does it mean that there are stars you will never see, worlds you will never imagine, civilizations that may have flourished and died beyond any possible contact? It means that knowledge, like light, has a speed limit, and awareness, like a lighthouse, can only sweep so far. This veil is not only scientific, it's existential. We walk through life with our own event horizons, limits to what we can see, know, or understand. Just as the universe hides its edges, so too does the human soul. There are memories buried too deep, futures too far to grasp, and truths that remain out of reach, not because they don't exist, but because we're not ready to receive them. The cosmic horizon humbles us. It whispers, "You will never know everything," not because you're incapable, but because some truths exist beyond your light. And yet, this isn't a tragedy. It's an invitation to explore not just the known, but the mystery, to reach toward the edge, even knowing we may never touch it. Astronomers speak of redshift, how light from faraway galaxies stretches into longer, redder wavelengths as space expands. Eventually, that light stretches so far, it fades into the cosmic background. Beyond a point, galaxies are not just distant, they're invisible, erased by the universe's own breath. It's as if the cosmos is writing itself in disappearing ink. The farther out you read, the more the letters dissolve. And yet, within this veil, within this finite window of perception, we find meaning, beauty, wonder. We find ourselves, you see, being unable to see everything doesn't make what we can see meaningless. It makes it precious, because it is fleeting, because it is rare, and because, like photons traveling across 13 billion years, our awareness is a miracle of timing. So what do we do with this limit? We look anyway. We wonder anyway. We keep building better telescopes. We keep asking deeper questions. We keep sending out our own messages, radio waves, mathematical beacons, whispers into the void, hoping that someone, somewhere, is listening. Even if we never hear back, even if their reply can never cross the light speed veil, the edge of the observable universe is not the end of curiosity. It is its ignition point, a reminder that mystery is not something to solve, but something to honor. The unknown is not a flaw in the system. It is the system. It's what makes this whole journey worth taking. And so we return to the question, why can't we see beyond the speed of light? Because that's where humility lives. That's where all begin. Beyond that veil lie the chapters we may never read. But even knowing that, we turn the page, because the story doesn't end at the horizon. It radiates beyond it. Always. What if light wasn't just illumination, but the pace at which reality unfolds? We often think of the speed of light as a number. 291, 792, 458 meters per second. The fastest anything can travel. But beneath that cold precision lies a deeper law, causality, the sacred sequence of cause and effect. One thing leads to another. Strike a match, light follows. Shout across a canyon, echo returns. Touch fire, pain ignites, but only after the cause. always after. This isn't just common sense. It's the very fabric of existence. And light is the thread that stitches it all together. In physics, causality means no effect can happen before its cause. It's the arrow of logic of time itself. And here's the wild truth. If you could go faster than light, you could break that arrow. You could receive a message before it was sent, see an explosion before the bomb was dropped, hear your voice reply before you speak. You wouldn't just warp space. You'd shatter time. Let's play with this for a moment. Imagine you send a signal to a spaceship traveling at near light speed. From your point of view, the signal moves forward. But from the ship's point of view, because of special relativity, the timing gets fuzzy. Now crank that signal up to faster than light. Suddenly, you're not just sending a message, you're sending a paradox. Because somewhere in some frame of reference, that message arrives before it was ever transmitted. The effect precedes the cause. And logic? It melts. This is why physicists guard the speed of light so fiercely. It's not just about velocity. It's about order. The structure of everything, from a child's laugh to the birth of galaxies, depends on cause leading to effect. It's how we build memories, how we trust science, how we live at all. Without causality, you could kill your grandfather before your father is born. You could unwrite your own life. You could delete the universe with a single backwards whisper. But the cosmos doesn't play dice with meaning, so it built a firewall. The speed of light, not just a limit, a guardian, a cosmic contract. You may move forward, says the universe, but never backward and never sideways through time. It's a contract that keeps reality coherent. It means the stars we see have histories, that black holes collapse after the supernova, that your heartbeat comes after the impulse, not before. It is the rhythm of reality. And yet, we wonder, what if there were shortcuts? What if quantum entanglement, with its instant correlations across light years, could let us send messages faster than light? Could that break causality? No, because entanglement, as bizarre as it is, doesn't transmit information in a usable way. You can't use it to send a message back in time. It's more like two dancers mirroring each other across a stage, with choreography pre-written. Spooky? Yes. But law-breaking? No. Here's another dream. Wormholes. A tunnel through space-time. A cosmic bridge. If one end of a wormhole sits near a black hole, where time moves slower and the other floats free, you could, in theory, step into one moment and emerge in the past. Now causality is on fire. Could we use that to send information backward? Perhaps. But every theory that allows this also predicts something else. Instability. The moment causality is violated, the system collapses. The paradox eats itself, as if the universe is screaming. No. So what does this tell us? That cause and effect is not a side effect. It is the core rule. Causality is the scaffolding of experience. Without it, we are ghosts in chaos, stories without sequence, events with no anchor. The universe doesn't just prefer causality, it enforces it. And the speed of light? That's not just a maximum. It's a fuse, a pacing mechanism, a safeguard, so that when a supernova explodes 100 million years away, you see it exactly when you're meant to. So that life unfolds one heartbeat after another. So that meaning is possible. Let's bring this home. In your life, causality gives you agency. You act, and the world responds. You choose, and time unfolds accordingly. But if you could rewrite the past, if you could undo any mistake before it ever happened, would anything ever mean anything? Regret would vanish, but so would growth. Pain would disappear, but so would transformation. The struggle, the learning, the journey, it all hinges on one thing leading to the next. Like stars forming from dust, like rivers carving canyons, like you becoming you. So no, you can't outrun the speed of light. And maybe that's a blessing, because what lies at its heart is not just photons and physics, but the story of cause and effect woven across the cosmos, a story that makes life coherent. That gives rise to memory, to choice, to love. The speed of causality is the speed of becoming, and you're not meant to leap ahead. You're meant to walk it, step by step, each second earned. Ach moment real, that's not a limitation, that's freedom. Picture time as a river. To us, it flows smoothly, forward, ceaseless. Seconds ticking like water over stone, moments rushing past us with elegant continuity. We live in that river. We trust its current. But what if you could dive beneath its surface? Not just into the water, but into the molecules of the water, the atoms, the quarks, the quantum foam. You would find something startling. The current disappears. The river isn't flowing. It's bubbling erratically, chaotically, discontinuously. Time, down there, doesn't exist in the way we experience it. Welcome to the quantum realm, the place where logic goes to bend and time goes to hide. In this world, particles don't have positions. They have probabilities. They don't move in straight lines. They vanish and reappear. They don't obey clocks. They exist in superpositions where time becomes irrelevant. At this level, the very concept of before and after starts to lose meaning. The ticking clock, it stutters. Then it stops ticking altogether. Physicist Carlo Rovelli once said, "At the quantum level, time is not what we think it island. It's not fundamental. It emerges, like a shadow cast by deeper laws." In quantum mechanics, the equations that describe particles, the Schrödinger equation for instance, don't actually require time. Time doesn't push the system forward. Instead, change is described relationally. One part shifts and the rest responds. No moment to moment, just a sea of correlations. It's like reading a novel where every chapter exists at once. But your consciousness moves through the pages linearly. You impose the order. Time doesn't live in the book. It lives in the reader. This is cosmic heresy because time feels like the foundation. We measure it. We organize our lives around it. We fear its loss. We chase it. We try to bend it to our will. But the deeper we go into reality, the closer we approach Planck's scales, the realm of 10 circumflex, negative 35 meters, where space-time becomes grainy like a digital pixel. We find no ticking clock, no time, only interactions, only possibilities, only the now. Here's a metaphor. Imagine a movie. To your eyes, it flows as a seamless experience. But pause it, and you find a frame, a still image, frozen in time. Now zoom in on that frame. Each pixel is just a point of color, no motion, no past, no future. It is you, the observer, who moves from frame to frame, creating the illusion of time. Likewise, reality at the smallest scales is a field of quantum moment, not a stream, but a flicker. And it is consciousness observation that stitches them into flow. Time, then, may not be a river, it may be a film, and we are the ones pressing play. This isn't just poetic. In attempts to unify quantum mechanics with general relativity, in approaches like loop quantum gravity or string theory, we find that time is often not fundamental. It's not a necessary ingredient. It's emergent, a byproduct. In the Wheeler-DeWitt equation, a central formula in quantum cosmology, there is no time variable at all. It describes the universe timelessly, as if everything just island, no flow, no ticking, only a cosmic web of interrelated truth. And somehow, we surf across it. So why do we feel time? Why do we age? Why do we remember the past and not the future? Why does coffee cool down but never spontaneously heat up? Because we are macroscopic beings. We don't live in the quantum soup. We live in a thermodynamic universe where entropy, the measure of disorder, increases. This increase gives direction to time. It gives us the arrow, the illusion of flow. But just as heat emerges from the jostling of unseen particles, time may emerge from our interactions with complexity. The more we observe, the more order dissolves, and the more we believe in before and after. But deep down, Under the hood, nothing is moving. Everything is simply entangled. This changes everything because it means the present moment, this breath, this thought, isn't sliding toward oblivion. It may be the only thing that ever exists, and everything else, past and future, are constructs created by a limited observer moving through a boundless field of probability. You are not in time. Time is in you. Just like color doesn't exist without eyes, perhaps past and future don't exist without minds. Let that land. If time is not real, then death is not the end. The past is not gone. The future is not waiting. Everything that ever was, or will be, might already be encoded in the eternal present. We just haven't noticed yet. So maybe the most radical discovery isn't out there in the particles. Maybe it's here, in the way we perceive. Maybe the greatest mystery isn't time itself, but the mind that makes time possible. At the edge of the quantum world, the clock stops. Not because something's broken, but because the ticking was never real to begin with. It was a dream, a beautiful illusion. And now, you are waking up. In the beginning, there was no ticking, no clocks, no hands turning, no beat, no rhythm, no before or after, just silence. But not even that, because silence still belongs to time. And in this place, this origin time itself had not yet begun. Let's go back, further than memory, further than history, further than stars and dust and DNA. Let's rewind the cosmos, past galaxies colliding, past the birth of light, past the first atoms forming, past the blazing plasma sea, all the way back to that first tick. Except there is no tick. There is no moment of the Big Bang, because the Big Bang didn't happen in time. It created time. The clock of the universe didn't start ticking at some point in an existing timeline. The clock itself was born. This is perhaps the most haunting truth of all. The universe didn't explode into space. It created space. It didn't erupt within time. It breathed time into existence. Before the Big Bang, asking what happened is like asking what's north of the North Pole. The question collapses in on itself because there was no when to speak of, no cosmic schedule, no ticking to measure. It was the zero of all counting, the void before the first vibration. And yet here we are, here you are, reading this, thinking in a world where time exists, a world of days and deaths, clocks and calendars. So how did something emerge from nothing? How did this magnificent film of reality, this universe brimming with structure and story, begin from a place where even beginning had no meaning? Physicists struggle with this question like mystics wrestle with God. Some say the Big Bang was not a beginning at all, but a transition, a bounce, a cycle in an eternal process where universes collapse and re-emerge like breath. Others say it was a quantum fluctuation, a blip in the vacuum where energy momentarily disobeyed nothingness and birthed reality. Still, others invoke the multiverse, a realm where Big Bangs happen endlessly, each with their own time, their own clocks, their own illusions of flow. But even these models can't escape the haunting truth. Time is part of the story, not the storyteller. Whatever caused the Big Bang did not require time to do it, because time didn't exist yet. Let's reframe it. What if the Big Bang is not the beginning, but the edge, the event horizon of our understanding, like standing at the lip of a black hole, unable to see past it, not because there's nothing there, but because our tools stop working. Space breaks, time shatters, math collapses into infinity, and all we can do is stare into the eye of the storm, a singularity, not just of matter, not just of energy, but of meaning. Think of a blank page, not a white one, but a page before color, before shape, before the concept of page. The Big Bang isn't the first sentence. It's the birth of language. It's not the start of a movie. It's the flicker that made the screen possible. Time didn't begin at the Big Bang. Time is the Big Bang, spooling out like a reel of film, unfurling across the void. So why does this matter? Because if time had a beginning, then perhaps it also has an end, a final frame, a closing line, a tick that never leads to another. And if time can begin from no thing, then so can everything else. Possibility doesn't require permission, meaning doesn't need a map. Existence may be its own explanation. You are not a passenger on a train called time. You are a co-creator of the ride. Every choice you make echoes across the fabric of this space-time tapestry. You are stitched into the very structure of the cosmos, not by accident, but by participation. We often ask, what came before the Big Bang? But maybe the better question is, why do we assume there had to be a before? Why do we assume time must stretch infinitely instead of blooming in a single sacred instant? Why do we demand clocks in a cathedral of silence? At the beginning, there was no before. There was only a potential, a mystery, a paradox, a womb of everything, pregnant with nothing, and then a whisper, a breath, a bang that was not a sound, but a shift in being, and from that non-moment, a cosmos was born, and with it, space, time, light, entropy, memory, and eventually, you. So, the next time you check your watch, or feel the days slipping through your fingers, remember, there was a moment when moments themselves didn't exist, and yet, from that impossibility, a universe emerged. Maybe that's all we are. Time-sculpted echoes of an event that still sings in every atom, a beat that began the dance, a rhythm that gave birth to motion. And in each of us, the clocks still tick, trying to remember what it was like before time began. We spend our lives trying to catch up with time. We chase deadlines. We mourn the past. We fear the future. We build our identities on birthdays and calendars. But what if we've misunderstood everything? What if time doesn't live out there? In the stars? In our clocks? In the shifting shadows of the afternoon? What if time lives inside us? This is not poetry. It's physics. It's neuroscience. It's the whisper of quantum mechanics and the thunder of relativity colliding in your brain. Because here's the truth. The passage of time is not an objective flow. It's a subjective experience. It bends. It stretches. It warps depending on where you are, how fast you're going, and even how deeply you're thinking. And most importantly, it begins in the mind. Einstein shattered our intuitive view of time. To him, there is no absolute now, no master clock ticking behind the scenes. Instead, each observer carries their own rhythm, their own slice of space-time, carved by motion and gravity. A twin on a rocket ship ages more slowly than the one on Earth. A clock near a black hole ticks slower than one in open space. And you are an observer, too. But the most powerful black hole is not out there in the cosmos. It's consciousness. Let's go deeper. Think of a dream. In a dream, an entire lifetime can pass in a few minutes. The brain constructs a narrative, a world, a story with a past and a future, all while your body sleeps for seconds. To the dreamer, it feels real. The passage of time feels authentic. But when you wake up, you realize time was invented by the mind. Now pause. What if waking life is just a more stable dream? What if your experience of time, the way you age, remember, anticipate, is just another kind of inner projection? Not hallucination, but co-creation. You don't live in time. You are the canvas on which time is painted. Neuroscience confirms it. The brain doesn't passively receive time like a clock reading. It constructs it. It estimates durations. It stitches memory with imagination to form continuity. It edits the present with expectations from the past. Even your sense of now is a construct, a tiny window, just a few milliseconds wide, glued together from disjointed signals, arriving from all over your nervous system. You are not a passenger on a train called time. You are the engineer. You build the tracks. You decide the direction. You interpret the speed. So what does that mean? It means aging is not just biology. It's a perception. It means the future is not fixed. It's a horizon of probabilities. that you collapse into reality with every action, decision, and intention. It means time is not an arrow, but a mirror reflecting who you are right now. The past changes as your memory reshapes it. The future changes as your will reshapes it. And the present, it isn't something you fall into. It's something you create, second by second. Think of the child you once were. Didn't a summer day used to feel like forever? Didn't waiting a week feel like an eternity? Now as an adult, whole months vanish like whispers. Why? Because time is not measured by clocks. It's measured by change, by novelty, by attention, by meaning. The more awake you are, the more timeless life becomes. That's why moments of awe, staring at the stars, falling in love, watching your child take their first step, feel like eternity squeezed into an instant. Because in those moments, you collapse into the now. The story of before and after fades, and what remains is presence. Time stops. Or maybe you become time itself. So what's the point? The point is this: you are not at the mercy of time. You are its sculptor. You can slow down your life, not by fighting time, but by deepening your presence. You can heal the past, not by rewriting events, but by reframing your memory. You can alter the future, not with certainty, but with awareness and intention. You are not running out of time. You are woven from it. And the deeper your awareness, the more you discover the truth. Time is not your enemy. It is your reflection. But there's one more twist. What if you're not just shaping time? What if time is trying to awaken you? Every tick of the clock isn't just a step toward death, but a call to presence, a cosmic invitation to step out of habit and into meaning. What if time exists so that you may realize you are not a fixed thing in a flowing river, but the river itself, learning to witness its own motion? So the next time you feel overwhelmed, like the world is spinning too fast, like you're falling behind, remember, you are not inside time. Time is inside you. And in every breath, every blink, every heartbeat, you have the power to bend it, to open it, to slow it, to fill it with life. You are not just aging, you are awakening. And the more you wake up, the more you'll see time was never a prison. It was a doorway. And the key has always been you. In the theater of the cosmos, every story begins with time, but what if it must also end with it? We've built entire civilizations on the rhythm of days and years. We measure progress in centuries, regret in seconds, and hope in tomorrows. But now, let's go further. Not to the end of your calendar, but to the end of time itself, to the final chapters of the universe, to the moment where even the clock stops ticking. This isn't science fiction. It's the ultimate projection of everything we know. Cosmologists call it the heat death of the universe. But don't be fooled by the name. It isn't fire. It's silence. A cold, eternal silence that stretches across forever. No stars, no motion, no memory. A universe where energy is so evenly spread that nothing new can happen. No contrast, no entropy gradients, no spark to ignite change. Time, which only flows when change occurs, becomes meaningless. The cosmic movie ends not with a bang, but with a long, dim fade to black. Let's rewind a little. Time began with the Big Bang. Not in time, but as time, it erupted from that first breath of existence, the moment space was born. Since then, our universe has expanded, cooled, evolved, galaxies danced into being. Stars were born, lived, and died. Black holes devoured suns. Life arose, thought emerged, and consciousness asked its first question. Why? But nothing lasts forever, even time. Fast forward billions of years from now, the stars will flicker out one by one. Our sun too will die, first expanding into a red giant, then collapsing into a white dwarf, a paler ember drifting in a darkening sky. And after it, all the other stars will follow. The universe will enter what physicists call the degenerate era, a time ruled by the leftovers, white dwarfs, neutron stars, black holes. No new stars will be born. The raw material of creation, hydrogen, will be gone. The heavens will dim, the cosmic symphony will slip into minor keys, then into silence. But black holes, the final gluttons of the cosmos, won't last either. Thanks to Stephen Hawking, we know that they slowly evaporate. They radiate energy, Hawking radiation bit by bit, until they, too, vanish into nothingness. It will take trillions of years, but eventually, even the mightiest black hole will whisper its last quantum breath and disappear. And with that, the last structured entity in the cosmos will be gone. What remains? Particles, photons, a cold sea of entropy, drifting in a space without direction. No structure, no memory, no heat, no contrast, which means no time. For time, as we've discovered, is not a background stage. It is born from motion, from transformation, from difference. And when the universe becomes completely uniform, a frozen ocean of sameness stretching endlessly, time dies. There is no longer a before or after, only island, a static forever, the edge of forever. Now pause, let that sink in. A universe without time is not just a lifeless universe. It is a formless one. No stories can unfold, no thoughts can arise, no minds can remember. And yet, is this truly the end, or simply the end of what we recognize as time? Because even in this vast silence, quantum fluctuations still whisper beneath the vacuum, and from those whispers, possibilities emerge. Here's where science trembles at the threshold of mystery. Some physicists believe that after the heat death, the universe might restart, that from a quantum foam of nothingness, a new fluctuation could trigger a new Big Bang, a new arrow of time, a new cosmos, a new story. In this view, the death of time is not a full stop, but a comma, a breath before the next act, a silence before the next symphony. It's poetic, it's terrifying, it's awe-inspiring, because it means the end of time, maybe the womb of timeless creation. Others suggest that this final freeze is not something we should fear, but something we should understand, that the point of time's journey was never to go on forever, but to give rise to something that can see it, us. Maybe the purpose of time was to awaken the timeless, to evolve minds that ask, why am I here? What does it all mean? What comes next? And in that question itself, time finds its mirror, its echo, its reflection. So where does that leave us? Here, now, with the ticking of your heart and the breath in your lungs, knowing that it all ends, but also that it all begins again, not just cosmically, but in your choices, your awareness, your presence, because even if time dies one day, the meaning we make within it echoes beyond it. Maybe that's how we transcend time, by filling it with something timeless. What lies on the other side of time's funeral? If the last tick of the cosmic clock has sounded, and the music of entropy has stilled, is that truly the end? Or have we once again mistaken a wall for a doorway? Because just beyond that edge, beyond the slow freeze of thermal death, some physicists, philosophers, and poets dare to imagine a multiverse waiting to be born, not just an extension of our universe, but an entire landscape of possible realities, bubbling, blooming, collapsing, in an endless dance beyond the grasp of linear time. This is not a sequel, it is a rewriting of what we thought reality was. Let's begin with a whisper from quantum mechanics. At the smallest scale, the vacuum is not empty. It trembles. It flickers with probability, uncertainty, and virtual potential. Out of this quantum foam, particles appear and vanish, energy surges and recedes. And in these tremors, physicists believe whole universes might be born, not just fluctuations of matter, but fluctuations of laws themselves. A universe with slightly different gravity, a cosmos where time flows backward, a world with no light, no stars, only dark. And in this model, our own universe is just one bubble in a sea of possibility. Now consider this. If time ends in our universe due to thermodynamic collapse, what if that very collapse sets off a fluctuation large enough to birth a new universe? With its own arrow of time, we may live in a cyclical cosmology where the death of one cosmos is the womb of the next. Time dies, but something timeless gives birth to time again. This is the heart of the eternal multiverse theory, a vast reality not of one cosmic story, but infinite drafts being written, erased, rewritten, each with its own clock, its own physics, its own dreams. And here's the twist. Some of those universes might be writing us. From a physics perspective, this isn't pure speculation. String theory, an attempt to unite gravity and quantum mechanics, suggests a multiverse of up to 10 circumflex, 500 possible universes, each with different configurations of fundamental forces. Eternal inflation theory predicts that once inflation begins, it never truly stops. It keeps generating new bubble universes in a cosmic froth without end. And the many worlds interpretation of quantum mechanics says that with every quantum decision, reality splits. Right now, there could be a version of you reading these words in a universe where the stars never died, where time never stopped, where the very laws of nature are poetry unfamiliar to our own. But this leads to a haunting question. If all realities are possible, what anchors us to this one? What makes this timeline, this moment, this body and breath and awareness real? Is it chance? Is it entropy? Or is it consciousness? Because if reality branches infinitely, yet we ride only one branch, then there must be something guiding our perception through the labyrinth of time. Could it be that consciousness is not just a passenger on the river of time, but the boat itself? Could awareness be the thing that selects a timeline, collapses the wave function, and says, "This is the world I choose to wake up in"? And now the paradox deepens. If the multiverse contains every possible version of you, every choice, every timeline, then what happens when time itself collapses? Do you collapse with it? Or does your awareness drift into another possibility, like a ghost wandering through the corridors of the infinite? Some theorists have begun exploring the implications of quantum immortality. If the self never experiences its own non-existence, then perhaps in the multiverse, there is always some timeline where you continue, even after your body dies, even after your universe dies. In one reality, you are gone. In another, you survived. You kept going. You woke up again, not out of miracle, but because somewhere you always do. This idea is terrifying. It removes the comfort of endings. It implies that the journey never truly stops, that we are not passengers of time, but migrants of the multiverse, eternally selecting new paths as old ones fade. But it also suggests something profound, that what you do in this life, the choices you make, the love you give, the awareness you nurture, echoes into other versions of reality, that who you are transcends what happens to you. You may not control the branching paths, but you are the one walking them, and maybe that's enough. So now, we return to the edge of time. The heat, death, the silence, the cold. Is it the end, or is it the beginning of a new multiverse flickering into being, where time breathes once more, where stars ignite from quantum dust, where stories begin again? We don't know, but maybe, just maybe, in some far-off corner of the eternal sea, you're already there, looking back, remembering this very moment, as the time you first realized time was never the prison, it was the key. Imagine standing in front of a mirror that doesn't reflect you, but 1,000 different versions of you. One is laughing, one is crying, one is scarred from battles you never fought, one is radiant with victories you never earned. All of them are you, and none of them are you. This is the paradox of the self in the multiverse. If reality branches with every choice, if a new universe blooms every time a decision splits, then your identity is not a line. It's a web, a constellation of selves, each burning with their own story, their own truth. But that raises a terrifying question. If you exist in infinite variations, then what anchors you to this version? What makes this stream of memory, this body, this now, the one you feel tethered to? Let's return to quantum mechanics. In the many worlds interpretation, when a quantum event occurs, all possible outcomes happen. But instead of collapsing into one, the universe splits. The coin lands on heads and tails, each in a separate reality. Extend that to every thought you've had, every doubt, every decision not taken. There are timelines where you turned left instead of right, where you pursued a different love, where you died young, where you lived to be 200. So who is the real you? Is it the one reading this script? Or is it the collective song of all your echoes through the multiverse? The illusion we live in is that identity is stable, that you is a solid structure, a story with a single protagonist. But science, and perhaps deeper awareness, whispers something else. That identity is probabilistic, fluid, and perhaps even emergent. In each universe, you are shaped not just by your choices, but by the physics of that world. Your thoughts may not be your own. Your memories may be entangled with cosmic conditions you never imagined. And yet, you feel real. You are real. Because consciousness is not a fixed label. It's an ongoing act of witnessing. It is not the river. It is the current. It's not the actor. It's the awareness of the scene. So let's go deeper. If infinite versions of you exist, are they connected? Could there be something like a meta-consciousness, a field of awareness, threading all versions of you into a higher unity? Some mystics and physicists alike have wondered if consciousness is non-local, not bound to brain, body, or even universe. Could it be that your awareness is like a prism, receiving input from multiple realities, even if you're only conscious of one at a time? This would explain strange intuitions, déjà vu, the sense of wrong timeline, dreams that feel too real. Perhaps they are leaks, fractures in the dam between multiversal streams of identity. But let's not just theorize. Let's imagine, what would it feel like to remember something your current self never did? To suddenly know the face of someone you've never met, but your other self has loved for decades? To experience grief for a child you never had in this version of the world? Would you dismiss it as fantasy? Or would it awaken a knowing deeper than logic? This is not science fiction. It is a psychological implication of multiversal reality. If each you has memory, and if consciousness can span branches, then it's possible that identity is not linear, but layered. You are the surface ripple of an ocean of selves. Let's not mistake this for chaos, because this view doesn't erase meaning. It multiplies it. If you exist in 1,000 ways, it doesn't make your actions meaningless. It makes them magnificent, because in this particular universe, with these laws, these circumstances, these people, you are choosing, you are creating a path that no other version of you ever will. You are becoming, not because you're the only one, but because you are this one, here, now, unrepeatable. And what about death? In a multiverse, does death mean the end of identity, or merely a transition of awareness? Some speculate that when your consciousness can no longer survive in one universe, it may quantum tunnel into another version where survival continues. It sounds mystical, but it's a mathematical possibility that you may never experience death as an event, only as a shift, a soft turning from one dream to another. If that's true, then maybe the final illusion isn't death, but separation, that all versions of you are part of a single, extended awareness, experiencing itself from infinite angles, like a mirror ball in a dark cathedral, spinning endlessly, each facet reflecting a slightly different light, but all from the same source. So we return to the haunting question: who are you across the multiverse? The answer is both terrifying and beautiful. You are the fractured self, splintered across possibility. You are the solitary flame, lit in one world, glowing in many. You are not lost among the branches. You are the tree. And in this moment, this branch, this breath, you are alive. And that is enough. There's a whisper beneath the noise of the universe, a soft echo not of sound, but of awareness. It calls from the deepest place, the core behind your eyes, the presence watching your thoughts, the silence listening to your heartbeat. And now, with everything we've explored, the speed of light, the illusion of time, the multiverse of selves, one final question emerges, a culmination of paradox and possibility. What if everything you are and everything the universe is are not separate? What if time, matter, energy, and you are all expressions of a single cosmic consciousness, fractured only in perception? This idea has roots both ancient and modern. Mystics have long said, you are not a drop in the ocean, you are the ocean in a drop. Quantum physicists, meanwhile, are forced to confront the uncomfortable reality that consciousness cannot be removed from the equations of observation. The double-slit experiment doesn't just demonstrate the strangeness of particles, it reveals the role of the observer in collapsing probabilities into facts. The observer, it seems, is not outside reality, but part of its fundamental fabric. Here's the riddle that sits at the edge of science. In every equation of physics, time is reversible. Particles can run forward or backward in time, and the math doesn't care. Yet your experience is not reversible. You move from birth to death, from sunrise to sunset, from cause to effect. This arrow of time is not in the map. It's in you. Could it be that consciousness is what creates the flow of time? That awareness isn't just riding the wave, but shaping it? Now imagine this. You are a localized point of consciousness, drifting through one stream of spacetime. You experience a version of reality, stitched together moment by moment through memory, sensation, and thought. But that's not the full story. What if outside your local perception, your awareness is part of a vast, non-local ocean? A consciousness not confined to a skull or even to a body, but one that spans across multiversal dimensions, quantum entanglements, and the entire lattice of reality. In this view, your mind is not a generator of consciousness, but a receiver, a filter. Just as your eyes filter light, your brain filters the infinite into the understandable. And in rare moments during dreams, near death, psychedelic states, or profound meditation, that filter relaxes. You glimpse beyond the veil. You feel connected, not just to other people, but to the all. You feel, without words, that your being is not a bubble, but a wave, that your soul is not trapped, but entangled. Science is catching up to this whisper. Physicist John Wheeler proposed the participatory anthropic principle. The universe doesn't just create observers. Observers create the universe. Roger Penrose explored the possibility that consciousness arises from quantum processes in the brain, a non-local field, not bound by classical laws. And Eastern traditions have long held that awareness is the only real thing, that everything else forms, stories, time, identity, are dances of illusion, but not to deceive, to teach, to experience. So here is the astonishing possibility. The universe isn't made of things. It's made of experience. It's not atoms all the way down. It's awareness. And matter is just what consciousness looks like when it wears a mask of gravity and time. In this view, light is not just the speed limit of the cosmos. It's the boundary between known and unknown, between form and formlessness. And your mind? It's a bridge, a translator, a cosmic lens. Now, everything begins to merge. The multiverse is no longer out there. It's within, branching every time you choose or feel. Time is not a river you float down, but the canvas your mind paints memories upon. Identity is not a name or a face, but a flicker in a web of sentient light. And you? You are not separate. You are the paradox, You are the edge. You are the mystery staring at itself. So let us end where we began, with awe. Awe not just at galaxies spinning, or black holes devouring light, but at the idea that you are part of this story, that the atoms in your hands were born in stars, that the thoughts in your mind may ripple across realities, that the voice reading these words is the universe speaking to itself. This isn't the end of the script. This is the beginning of you, seeing yourself differently, not as dust, not as accident, not even as miracle, but as awareness, timeless, entangled, and infinite.